Jai Hind everyone, I am Dr. Ekta Pandey from the Department of Applied Science and Humanities, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss a topic probability mass function and probability density function from the module 4 Statistical Technique 2 from the course Mathematics 4. In this video lecture, I am going to discuss about random variable, continuous random variable. It can be continuous random variable or discrete, and next probability function of this random variable, which can be a probability mass function or probability density function. So let us start the lecture, and first of all we must know what is random experiment. See, an experiment is called random experiment if it is satisfying two properties. The first one is it has more than one possible outcome, and the second property is it is not possible to predict the outcome in advance. See, I am going to take an example, and the experiment is tossing a coin. If we toss a coin, then any one of the two possible outcome, head or tail, can appear, and we cannot predict the outcome in advance. See, this experiment has more than one possible outcome, head or tail, and it is not possible to predict the outcome in advance. So this experiment is a random experiment. Now, let us see what is random variable. Corresponding to any random experiment, we can define a variable which is known as random variable. This variable stores a numerical quantity to each and every possible outcome of the random experiment. See, we can understand this definition by taking an example. I am going to toss 3 coins simultaneously. Then, in this experiment, the possible outcomes will be, we can obtain head, head, head on all the coin, or head, head, tail, 2 head and 1 tail, or third possibility is this, head, tail and head, and next possibility can be this. Next possibility can be we got tail on each of the coin, or 2 tail, or this possibility can be obtained, or this possibility can be obtained. So I have listed all the possible outcome of the experiment of tossing 3 coins simultaneously. Now see, here corresponding to each possible outcome, I can assign a number, and see, for the first outcome, I can read it as number of head. How many head I obtained? 3 head. For second possibility, number of head is 2. For third possibility, number of head is 2. For next possibility, number of head is 2. And for this possibility, number of head is 0. And for this one, number of head is 1. For this one, number of head is 1. And for this one, number of head is 1. So corresponding to each possible outcome, I have assigned a number. This number is the number of head. So I am going to take a random variable that denote the number of head. Then this variable will contain 4 elements, 0, 1, 2 or 3. So we have 0, 1, 2 and 3, the possible values of the random variable x. Now see, this variable now has a specific range. The range of this variable is from 0 to 3, and corresponding to each value of this variable, we can also find a probability. See, how can we find the probability? We know that the formula of probability is number of favorable cases upon total number of cases. So for the value 0, if number of head is equal to 0, then favorable case is only 1, and see, the total cases 1, 2, 3, 4, 5, 6, 7, 8. Total cases is 8. So the probability of having a random variable value 0 is 1 by 8. Now, for the value 1, the probability will be 1 is number of head is 1. So, favorable cases corresponding to 1 are 3. So favorable cases are 3 and total number of cases are 8. So the probability for x having a value 1 is 3 upon 8. For the value 2 means number of head is 2. The favorable number of cases is again, number of favorable cases are 3. So probability will be 3 upon 8. Next, for 3 means number of head is 3. The probability is obtained as number of favorable cases upon total number of cases. Now favorable number of cases, there is only one case. So probability will be 1 and total cases are 8. So probability is 1 upon 8. See, corresponding to each value of x, we have obtained the associated probabilities. Okay. Now, see, we have a table now. In this table, we have all possible value of random variable and the probability associated to each value. This table is known as probability distribution of the random variable. Okay. And in this table, you can observe the sum of probability. Find the total of these probability, you will obtain 1. So for any probability distribution, the total probability will always be equal to 1. And next, you can see each probability is lying between 0 and 1. For any probability distribution, particular probability will lie between 0 and 1. Next, for any impossible value, probability will be 0 for any impossible value. Impossible value means since we are tossing the coin 3 times or 3 coins are tossed, so number of head cannot be 4. So probability corresponding to 4 will be 0. These are 3 properties for the probability. These are 3 properties for the probability distribution. Next, now we are going to discuss about the type of random variable. See, we have 2 type of random variable. The first one is discrete random variable and second one is continuous random variable. In case of discrete random variable, the variable will be assigned isolated values only. For example, the experiment that we have discussed in the previous slide, the random variable was number of head. So number of head is a discrete value. If we are going to toss a coin 4 times, then the random variable number of head will contain the value 0, 1, 2, 3 and 4. These are all discrete values. And second one can be, random variable can be continuous. See, in case of continuous random variable, the value of variable can assume any value within an interval, defined interval or required interval. So value of the random variable can lie within an interval. It can take any value within an interval. For example, see, height, weight, wages, pressure, all these variable are continuous variable. We can have height 55.4, 55.6 inches, or in this interval 55 to 56. We can have any height 55.2, 55.3 or any value can lie in this interval for the variable height. So height, similarly weight or wages, pressure are the continuous random variable. Next, we are going to discuss about the probability function. See, this one. This is a probability distribution table and you can see in this table the value of the random variable are 0, 1, 2 and 3, and see, corresponding to each value I have obtained the probability by using the formula of probability. The formula was total number of favorable cases upon total number of cases. But see, in many cases, we can observe a mathematical relation between the probabilities and the corresponding random variable. If we can find or derive or we know a functional relationship between the random variable and its probability, then it will be easy to find the probability. We have no need to find the probability for each and every value by counting the number of favorable cases, by counting the number of total cases. Instead of these, what we can do, just put the value of random variable in this function and we can find the corresponding probability. So no need of counting number of favorable cases or number of total cases every time. This functional relation is known as probability function. So if we can find a probability function, then it would be easy for us to find the probability for any value of the random variable. This probability function is also called as probability distribution. We also call it as probability distribution. Now, depending on the nature of random variable, it can be classified as probability mass function or probability density function. So, let us discuss about the probability mass function and probability density function. First, I am going to discuss about the probability mass function. Just on the basis of the nature of random variable, we are defining the two probability function. Here, a function that describe the probabilities of discrete random variable. For a discrete random variable, if we are finding a relation, a mathematical relation which is known as probability function, then this function is known as probability mass function. And as we have discussed, any probability distribution or probability function satisfies three properties. The first one is particular probability will lie between 0 and 1. Always, for any impossible value, probability will be 0 and total probability will always be equal to 1. Okay, for example, probability mass function, some example of probability mass functions are binomial distribution and Poisson distribution. You can find the video lecture on these two distribution. Next, I am going to discuss about the mean and variance of the probability distribution of the random variable. If we have a probability distribution of a random variable, then we can find the corresponding mean and variance. See how? You must know for a frequency distribution, the mean is given by summation fx upon summation f, where f is the corresponding frequencies. Okay, and variance is given by, for a frequency distribution, 1 upon summation f x minus x bar raised to the power 2. These are the formula for mean and variance for the frequency distribution. But here we have a probability distribution. So what we have to do, just replace the frequency by probability. So for probability distribution, mean will be x into px divided by total probability, sum of all probability. But you know total probability is equal to 1. So for a probability distribution, mean is given by sum of x into px. And similarly, the variance for a probability distribution is given by summation. Now we will use a probability function x minus x bar raised to the power 2 upon sum of total probability. But we know that total probability is equal to 1. Sum of all probabilities means total probability, and we know that total probability is equal to 1. So variance is equal to sum of px into x minus x bar raised to the power 2. This is a formula for variance. Okay, and you can simplify it. We can apply some mathematical calculation. Then this sum can be expanded and can be written as sum of x square px minus mean raised to the power 2. So finally, for variance, we obtain the formula as x square into probability function and its sum minus mean raised to the power 2. So these are the two formula. One is the for mean and one is the for variance. Mean is also known as, in case of probability distribution, mean is also known as expected value of random variable. So if we want to find the expected value of random variable, then what we have to do, just find the mean. So let us move. Next, we are going to take an example, and in this example, we have a probability distribution, and what we have to find, expected value and variance of the random variable. So what will be the first step? Just write the formulas for the expected value and variance. We know that expected value is mean of the probability distribution, which is equal to x into probability. Okay, and second one is the formula for variance, and variance is equal to summation of x square into probability minus mean raised to the power 2. These are the formula for mean and variance, and according to these formula, what we have to find, read it carefully and just think what we need. We need x into px and x square into px for each value of the random variable. So make a table of calculation. Here we have first column for the value of x, second column for the corresponding probability. Now what we need, x into px. X into px is obtained by just multiply the corresponding values of x and its probability. 1 into 1 by 2, 1 by 2. 2 into 1 by 3, 2 by 3. 3 into 1 by 6 is equal to 1 by 2. Now just find the sum, and this sum is x px, means we have obtained the value of mean. Just add these all values, these values. When we add these values, we obtain summation x px, which is equal to mean. So we have obtained the value of mean. Mean is equal to 5 by 3. Now next we have to find the variance. How can we find the variance? To find the variance, we need x square into px. So corresponding to each value of x and px, just find the value of x square px. 1 raised to the power 2 is equal to 1 into 1 by 2 is equal to 1 by 2. 2 raised to the power 2 into 1 by 3 is equal to 4 by 3. 3 raised to the power 2 into 1 by 6 is equal to 3 by 2. Now just find this sum, and this sum is summation x square into px. Okay, we have obtained the sum. Now to find the variance, what we have to do, just subtract the mean from this mean raised to the power 2 from this sum. So variance will be 10 by 3 minus, it is minus, and mean was 5 by 3. So subtract 5 by 3 raised to the power 2 from 10 by 3 and simplify it. We obtain the variance for the probability distribution. I hope you are getting my point. So by using these two formula, mean and variance, we have obtained the mean and variance of the given probability distribution. Let us take one more example. And here in this example, again we have a probability distribution, and we have to find the value of k and these two type of probability. Okay, so let us start from the first part. We have to find the value of k. See here, corresponding to each value of the random variable, we have probability in terms of k. Okay, and we know that for any probability distribution, the total probability is equal to 1. Means if we find the sum of all these probability, then this sum will be equal to 1. So just add all these probability. We obtain 10k square plus 9k, which will be equal to 1. Now simplify this equation. 10k square minus 9k minus 1 is equal to, this is plus, minus 1 is equal to 0. This is a simple quadratic equation in k. You can find the root of this equation and we will obtain k is equal to 1 by 10 and minus 1. Now see here, we have two values of k, but we cannot have negative value of probability. See, k is a probability now, so we cannot have a negative value of k. So we cannot take this value of k. What will we take? We will take 1 by 10. So we have obtained the value of k. Now come to the second part. In second part, we have to find the probability x greater than equal to 6. See here, x is greater than equal to 6, means x can take value 6 or 7. Okay, now you can apply the addition law of probability. then this probability can be obtained by x equal to 6 and plus a probability of x equal to 7. From the table, we have a probability of x equal to 6 is equal to 2k square, and probability of x equal to 7, the probability is k plus 7k square. So this is equal to 9k square plus k. Now what we have to do? Just put the value of k. 9 1 upon 10 raised to the power 2 plus, this is plus 1 upon 10. Just simplify it. We have obtained the probability of x greater than 6. Next, for the third part, see, for the third part, we have to find the probability of x lying in between 3 and 6. See, here we have equal to for the boundary 6, but less than for the boundary 3. So, keeping it in view, the x variable can take the values x equal to 4 or 5 or 6. X can take values 4 or 5 or 6. Now again, by addition law of probability, we have x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6. And from the table, we have all these probability. For x equal to 4, we have probability 3k. For x equal to 5, probability is k square. And for x equal to 6, probability is 2k square. This implies the probability for x lying in between 3 and 6 is equal to 3k square plus 3k. Now just put the value of k and just simplify it. You can obtain the probability. Just simplify, nothing else we have to do. This one is 3. Okay, so I hope you have understood this example of finding the value of k or any probability from the given probability distribution. Now, let us discuss about the probability density function. We are going to discuss probability density function. See, what is a difference? Just instead of discrete variable, now we are taking a continuous variable, and any probability function, a mathematical relation which can describe the probability for a continuous variable is known as probability density function. Okay. Now see, if we can derive or we are given or we know a probability function which is denoted by fx for a continuous variable, continuous random variable x, then we can find the probability of x falling in the interval a and b. How? We can find this probability of x lying in the interval a and b by applying the integral on the probability function in the interval a and b. Means just we have to find the integration of fx, means probability function, in the interval a and b. See, we can discuss how this integral we have obtained, how this integral we can discuss it in this form. What is this form? If x is a discrete variable instead of continuous variable, think the situation when we have x as a discrete variable, then probability of x lying in the interval a and b can be obtained just by addition law. How? See, if this is a real line, and this one is x equal to a and this one is x equal to b. Now x is lying between a and b, so x can take any value in this interval, this one or this or this or this or this or this or this or this. Now you can observe that we can find this probability by OR law of probability, means addition law of probability. So by addition law of probability, what we have, probability of x lying in the interval a and b is equal to probability of x is equal to x1 or x2 or x3 or and so on. So just applying the addition law of probability, it will be equal to probability of x1 plus probability of x2 plus probability of x3 and so on. Means probability of x falling in the interval a and b can be obtained by finding the sum of all these probability moving x from a to b. Okay, but since x is not a discrete variable, see, if x is a discrete variable, then this sum can be obtained by sigma. Sigma stands for summation for the discrete variable. But if we have a continuous variable, then instead of sigma, this sum can be obtained by integration. This sum can be obtained by integration. So I hope you have understood this point, that in case of continuous variable, if we are applying addition law probability, then this probability is obtained by integration, as we have to find the sum, and this sum in case of continuous variable can be obtained by applying the integral. Okay. Next, one thing more that we should discuss about the continuous variable. See, in case of continuous variable, I am talking about the probability in an interval, not about a particular value of the random variable. Okay, see, why? It will be very absurd to ask what is the probability that a boy has a height 55.4 inch. See, it is very difficult to find a boy in your class that has a height of 55.4. Instead of it, we can find a boy who has a height between an interval 55 and 56. So from this example, you can understand that in case of continuous variable, we always talk about the probability in an interval instead of probability of a particular value of random variable. Okay, so for a continuous variable, decimal probability for a decimal value will be a very rare question. So instead of finding this probability, we used to find the probability of x lying in some interval. Okay, I hope you are getting my point. And the next one, which is very important to note for a probability density function, is that in case of continuous variable, this equality or equality sign means I am talking about this. This equality sign does not matter. You put it or not put it, all these probabilities are equal to each other. But if it was discrete variable, agar we have this variable as a discrete, then we cannot have all these probabilities equal to each other. Okay, but in case of continuous variable, this equality does not matter. We have this one or this one or this one or this one. All these probability will assume the same value. So these are the some important point about the probability density function. So I hope you have understood that from where this integral has came in this formula. Okay. Now again, for like any probability distribution, again this probability density function will also satisfy these three property, and the properties are: first one, any probability for any value of random variable will be lying in the interval 0 and 1. For any impossible value of x, probability will be 0 and total probability will be 1. Now you know the total probability was given by summation pxi, and I was going from 1 to n say, and it was equal to 1. Total probability was equal to 1, which was given by sigma. It stands for summation for a discrete variable. But in case of continuous variable, instead of using this sigma, we use integration. From where to where? If random variable is defined for the range minus infinity to infinity, then just integrate the probability function from minus infinity to infinity. This is total probability, which will be equal to 1. One of the example of probability density function is normal distribution. You can find the video lecture on the normal distribution on AKGEC digital education platform. Now let us discuss the mean and variance for the continuous probability distribution, continuous probability distribution. See, we have discussed the mean and variance of the probability mass function, means for the discrete random variable, and the formula was summation x px was the formula for mean, and for variance it was x square px minus mean raised to the power 2. This one was the formula for mean and this one was the formula for variance. But in case of continuous variable, instead of sum we will use the symbol integration, means instead of getting the sum we will integrate the value x fx from the prescribed range. If x is taking the range minus infinity to infinity, then just integrate x into fx from minus infinity to infinity. We will obtain mean. And variance is obtained by just integrate x square into px from the prescribed range, say minus infinity to infinity, and just subtract mean raised to the power 2. We will obtain the variance. So the only difference is here we are using summation or sigma sign. Here we will find the integral. See, one of the example is given in this slide. We have defined a function given by c e raised to the power minus x, and x is taking the value from 0 to infinity. We have to find the value of c, which changes the fx to a probability density function. See, we have to find the value of c such that this function, we have defined this function should be a probability density function. How can we find? Just we apply the property of probability density function. We know that the total probability is equal to 1, and total probability can be obtained by integrating the probability function from the prescribed range. The range of the variable is 0 to infinity. So just what we have to do, just integrate the given function from 0 to infinity, which will be the integration will be equal to 1. Now put the value of the function and just solve this equation for the c. You will obtain c is equal to 1. So for c is equal to 1, this function can be taken as probability density function. This function can be taken as probability density function. Okay. Next, in this example, we again have a probability density function fx is equal to k x square into 1 minus x cube. We have to find the value of k and mean and variance. This is very simple and very important example. You know that the total probability is given by integration of probability function between the prescribed range. The range of the random variable is 0 to 1. So just find the integration of probability function from 0 to 1, and this integral will be equal to 1 as the total probability is 1. So just solve this integral equation for the k. You will obtain k is equal to 6. It is very simple to find the integral of this function. So just solve this equation for the value of k and we will obtain k is equal to 6. Next, we have to find the value of mean. We know the formula of mean is just find the integral of x into fx in the range 0 to 1, because the random variable is taking the range of 0 to 1. So just put the value of fx, multiply it with x, we obtain x cube minus x raised to the power 6. Find this integral and multiply it by 6. Why? Because k is equal to 6. So just we have the function now, because k is equal to 6, therefore function is 6 x square 1 minus x cube. What you have to do, just multiply this function by x and integrate it in the range 0 से 1. We will obtain 9 by 14. This is the mean of the probability density function. And variance, we know that the formula of variance is x square into fx. We will find x square into fx, then integrate this function in the range 0 से 1 and then subtract the mean raised to the power 2. Okay, so this is the function. Multiply it by x square. We obtain 6 into x raised to the power 4 minus x raised to the power 7. Integrate it in the range 0 से 1 and subtract 9 upon 14 raised to the power 2. We obtain 9 upon 245. So I hope you have understood how we can find the mean and variance of a probability density function. So that's all about this lecture on probability mass function and probability density function. Thank you so much.